back. I am on take number 3 of exponential functions here as we continue our study of exponents. Uh, Hopefully the interruptions are done. I can get this through in one little jiffy here. So exponential functions, and we're going to work through some realistic, real-world problems here, as opposed to just kind of doing some boring old 2 to the x equals 24, find x. So we'll jump right into it, of course. Make sure you recall that we have our function notation for the equation a b to the x, where b is your base. Okay, what are we multiplying by? A is your constant. What are you starting with? Constant or starting? And this is our multiplier, the base. Are you doubling it? Is it a 6% increase? So the multiplier would be 1.06, like you got sales tax. And x is obviously our exponent. And more often than not, in real-world examples, the exponent will be your time. Okay, more often than not always. All right, so let's jump right into this here. And I'm having a little lag here, connection lost. You can see that. So let me see if I can reconnect with my airliner. I'm moving around by hand. We are connected and rip-roaring, ready to go here. So let's say we are given a little bit of information. You're told f of 0 equals 3, and you're told f of 2 equals 12. And on top of that, you are told this is modeled by an exponential function. Modeled by an exponential function. And that's good to know, because otherwise, if you don't know if it's exponential, it could be linear, it could be quadratic, it could be cubic. A lot of different routes you can go. You know, are we doing ax squared plus bx plus c? Are we doing mx plus b? No, we are doing exponential. We know it looks like a b to the x. So just like anything else, you plug in. You know, in this particular case, we know these two examples. So let's plug in 12 equals a b to the second. And we plug in 0 and 3. So we also know that 3 equals a b to the 0. Well, this is a system of two equations with two unknowns. In this particular case right here, anything to the 0, remember, is 1. So that tells us a equals 3, which then we can go ahead and plug in up here. So 12 equals 3 times b squared, which means b squared equals 4, and that means that b equals plus or minus 2. Okay, don't forget your plus or minus when you take the square root, which means our general equation is one of two things. A is 3, that's locked in. Is it 3 times 2 to the x, or is it 3 times negative 2 to the x? Okay, and both are correct answers. One alone is partially correct, but not full credit correct, right? You need to make sure you know it could be either or. You'll have this kind of situation when you have an even exponent and you take that root, you'll get that plus or minus. All right, so there's one example of taking two given points. You know, you can find the equation of a line given 2 points. You can find the equation of an exponential given 2 points as well. So let's take another example here. A bank advertises that you can double your money. A bank advertises, let's say a bank says, you can double your money. You can do it. You can double your dough. Double your money. And what do you say? Let's go with 8 years by using their bank. So what interest rate does this bank give? And of course, there's extra information that would be nice to know, like is it a yearly interest? Is it monthly interest? We're just going to do a generic problem here. So we have the equation. Remember, they have tons of different forms. I'm going to do a of t instead of f of x equals a sub 0, b to the t. Okay, instead of a being x and y, I'm going to use the amount, my final amount, my initial amount, my base, which is my multiplier, and the amount of time. Well, I'm doubling my money, so pick a number. It makes no difference at all. Let's say I pick $500. Okay, so 500. I'm going to show you that it makes no difference at all. So 500 is going to get doubled. So that's my initial amount. 500 doubled is 1,000. All right, so $1,000 is my bank account. My initial amount is 500, and I'm multiplying by something, and I'm doing it over the course of 8 years. So this particular one is on a yearly interest plan, the way I'm setting this up. All right, first step is divide by 500, and I get 2 equals b to the 8th. So b equals the 8th root of 2. So let's see if I can do that on this calculator right here. Does not look like I have that option. So I'm going to jump over to our trusty TI-84 calculator and do the 8th root of 2. And it's coming, it's coming, it's coming. It is validating. Still validating. So I hope you guys are enjoying these videos here as this software is validating. Chance to fast forward over this if you'd like. Would recommend doing that. There's the large screen. So we are looking at the 8th root of 2. Remember, we know fractional exponents now, so I'm not going to do the 8th root. I'm going to do it to the 1/8 power. And there's our answer, 1.0905. 1.0905. Now, technically that's plus or minus, correct? Because I took the 8th root. However, we're talking about interest, so we don't really care about the negative. And this says that my multiplier is 109.05%, which means my actual rate is 9.05%, right? I start with 100%. I now have 109.05, so the rate is 9.05. And this is the annual percentage rate that you are given. Okay, so we're told annual percentage rate for that particular problem, and it will in fact double. Now I mentioned I'd show you it doesn't matter what number you choose here, so let me prove my point. Let's say we choose our amount to be K. Well, if you double K, you have 2K. So let's plug in. 2K equals my initial amount times some starting value over the course of 8 years. First step, divide by K, I get 2 equals b to the 8th. Notice the exact same equation. Okay, so it doesn't matter what you choose to be your starting amount. The fact that you're doubling it means it's going to be 2 equals at some point in the problem. All right, and the last piece I want to talk about here is something that actually makes this problem a lot quicker. It's called the rule of 72. Rule of 72. Well, my answer here is 9% over the course of 8 years. What's 9 times 8? Ding, ding, you got it. Winner, winner, chicken dinner. 9 times 8 is 72. The rule of 72 is a shortcut method of finding out how quickly things double. So let's say you have 10% interest. That means it'll double in approximately 7.2 years. Okay, or let's say you double in 5 years. Okay, if you're doubling in 5 years, 72 divided by 5 is what, 14.4? That means you're getting 14.4% interest. Okay, so 72 divided by the rate gives you the years, and 72 divided by the years give you the rate. And you can see that holds true with our example up here. 72 divided by 9 is 8 years, and 72 divided by 8 is 9%. Keep in mind, this is not a exact science, the rule of 72. It's a good way to approximate. So when you're in at a bank and you're talking about mortgages or interest rates, and they're saying, oh, your money market will double in 6 years, and you can look at them and say, I don't think so. I'm not getting 12%. It ain't doubling in 6 years. Okay? So you have a pretty good idea of whether the information they're giving you is accurate or not. We will continue with exponents and stuff further down the road and talking about more equations we can use with money and finance and mortgages and interest and things of that nature. Hope you enjoyed this video. Have a nice one.